Hello, my name is John and welcome to Victory Online Academy. In this video, we will discuss about gravitational force and orbital velocity. So this is a fate simulation software. This is satellite. It is our planet Earth. This blue line shows the gravitational force. As you know, gravitational force is an attractive force. So Earth is attracting this satellite. That's why it is pointing towards the Earth. And according to Newton's third law of motion, for every action there is equal and opposite reaction. It means if the Earth is attracting the satellite towards it, the satellite is also attracting the Earth in the opposite direction. So the satellite is attracting the Earth towards right side, and the the planet Earth is attracting the satellite towards left. Actually, this gravitational force acts as centripetal force which helps the satellite to move around the Earth. So this is showing the gravitational force. Here the velocity is always tangential to the path. I'll show you the path. So here the velocity is tangential to the path. This is showing the velocity of the satellite at this particular point. So here the velocity is changing because the direction is changing. Velocity is speed plus direction. Velocity is a vector quantity. So as the direction is changing at every point of the motion, that's why the velocity is changing. And if the velocity is changing, the body is accelerating. It means the satellite is accelerating. And the force which is helping in this acceleration is the centripetal force. And here the centripetal force is the gravitational force between them. And as you can see, the satellite is orbiting the Earth uh, in a circular orbit. These points are clear to you that gravitational force is always towards it. It's an attractive force, and they are equal in magnitude and opposite in direction. That is what universal law of gravitation or Newton's law of gravitation. And the velocity of the satellite is always tangent to the path, and the satellite is moving in a circular orbit. Now let's derive the formula to find out the orbital speed of the satellite, the value of the speed of the satellite, and let's see on what factors it depends. So before we derive the formula for orbital speed of the satellite, let's revise Newton's law of gravitation. The planet whose mass is m, and there is a satellite. This is a satellite which is revolving in a circular orbit at a radius, at a distance r from the center. So this is the satellite and whose mass is small m. So Newton's law of gravitation states that the force between them is directly proportional to product of their mass and inversely proportional to square of distance between them. So finally, if you combine them, you will get this formula Gmm over r square, where G is gravitational constant. So this is the value of the force which is acting between them, and as we have seen in the fate simulation software, that this is an attractive force, and they act in opposite direction. So the force acting on the satellite is by the planet Earth is inward, and the force the satellite is exerting on the planet is outward. Now this gravitational force is helping the satellite to move in a circular path. So this gravitational force is acting as a centripetal force. Okay, and centripetal force formula, if v is the speed of the object, the centripetal force is mv square over r. So here the centripetal force is the gravitational force. So to find out the orbital speed, what we will do is we will equate both of them, as the gravitational force between them is acting as a centripetal force for the satellite to move in a circular path. So this gravitation force Fg is the same as Fc, means gravitation force is equal to centripetal force. Okay, so gravitation force is equal to centripetal force. Gravitation force is G mm over r square. Fc is mv square over r. So mm gets cancelled out, small m now, and 1 r gets cancelled out. So v square is gm over r, and v is equal to square root of gm over r. This shows that the orbital speed does not depend on the mass of the satellite. It depends on the mass of the planet. And if you know the mass of the planet and the distance between the planet and the satellite, you can find out the value of v, because g is a constant. Thanks for watching the video. See you in the next video.